Hello, today we are going to discuss about in this lesson bolts of uniform strength. The objectives of this lesson, on completion of this lesson, you would be able to understand the concept of bolts of uniform strength, two methods of obtaining bolts of uniform strength, strength of screwed joints, and design of a nut. These four objectives we are going to discuss in this lesson. So now previously we have discussed nomenclature of screw threads. Now you can see in this nomenclature various definitions and various parts of this screw thread are. Number one, see here, this is the crest topmost point and the bottommost point is the root, and from one point to the another point on the consecutive thread along the axis is called a pitch. And now the lead, which is the distance advanced by the screw into the nut for one revolution, and it may be equal to pitch. The lead may be equal to pitch in case of single star thread, whereas for multi star thread, this is lead is equal to number of threads into pitch. Now here you can see this is the angle, thread angle, which is made between the two flanks, and this is called, this inclined surface is called flank, and this is called slope. Now here the diameters are, number one is the root diameter, that means from root to root, the distance perpendicular to the axis is called root diameter, or also called minor diameter, or also called core diameter. Whereas the another diameter is outside diameter, that is crest to crest distance, crest to crest perpendicular to the axis. This is outer diameter or outside diameter or nominal diameter, gross diameter, and major diameter we can call. And the difference from here to here, that means a perpendicular distance from root to crest is the depth of thread. This is all about the nomenclature as we have seen in the earlier lessons. Now let us see in this part. This is the shank part anyway, and this is from here to here, it is the threaded part. As you see, the material at this is more, whereas at this point the threaded portion, the material will be less. So here you can see, whenever there are a tensile forces acting on this bolt or screw thread, the more concentrations of stresses will be at the threaded portion only. That means in the bolt, the threaded portion is the weakest part, while the strongest part is the shank part. Let us see one by one. So from the figure itself, observe the least diameter of a bolt, which is its core diameter DC. That means that is the root diameter. This is called core diameter, minor diameter. Now weakest part of bolt, where the cross-sectional area is minimum. Wherever the cross-sectional area becomes minimum, that is core diameter will be the weakest part. So you can see A is equal to core area. That means area of the threaded portion at core diameter is pi by 4 DC square, where A is the area at root, that is A in millimeter square, and core diameter is equal to 0.84 times the nominal diameter d, where d is the nominal diameter in millimeters and dc will be the core diameter in millimeters. So you can see impact load on bolts. As we have seen IC engines, there is a cylinder, over that there is a cap or cylinder cover which is fixed to the cylinder either using studs or using bolts. So in case of bolts or studs, whatever it is, if you see this is the cylinder cover and there may be 5 bolts are there. In this case, during the working of IC engine, the forces are acting, impulsive forces or shocking forces are acting on the cylinder cover intermittently. That means during the other strokes there is no impulsive forces on the cover, whereas during the power stroke there are some impulsive forces are acting on the cylinder cover. So friends, here you can see in case of a cylinder head bolt of an internal combustion engine is subjected to impact or shock loading. That means this cylinder cover is subjected to either impact load or shocking loads. So with this, what is going to happen? In case of shocking load, the resilience of bolt should be considered in order to prevent breakage at the threads. That means the threaded portion will be the weakest part of the bolts. So the effect of these impulsive loads applied axially is concentrated on the weakest part of the bolt, that is cross-sectional area at the root of the threads, right? That means all these impulsive forces are going to be concentrated at the weakest part, that is at the root diameter, right? So here you can see, and what are the stresses are acting. So the stress concentrations in the threaded portion or the bolts will be higher than that of the shank. The stresses are concentrating at the threaded portion only, but not on the shank part, because the shank part is the strongest part when comparing to the stronger part when comparing to the threaded portion. That's why the stresses are concentrated at the threaded part only. The two on the root diameter. The two on the root diameter. Hence, a great portion of the energy will be absorbed at the region of threaded parts. That means major energy will be concentrated. That means will be absorbed by the threaded portion, especially core diameter parts, core area, right? So with this, there is a possibility of it may fracture at the threaded portion because of the concentration of more energy, especially at the core diameter. So how to make, as we have discussed so far, the bolt is not uniformly strength at the threaded portion as well as at the shank parts. That means the shank part is strongest part, whereas the threaded portion is the weakest part. Among the threaded portion also, root area will be the weakest parts. So how to make these bolts of uniform strength? So let us see the failure of threaded portion in bolts which are subjected to shock loading can be avoided by making bolts of uniform strength. That means the bolt should be made uniform strength throughout its length. That means at the threaded portion as well as the shank parts. So friends, you see how to make the bolts of uniform strength. how to make the bolts of uniform strength. Let us see, this can be achieved. That means uniform strength in the bolt can be achieved by reducing the shank area. By reducing the area of shank equal to the root area of the screw. That means the shank area should be equal to root area. With this, we can achieve the bolts of uniform strength. So with this modification, a greater force is permissible due to uniform distribution of stress. That means you can achieve with this, the total becomes uniform throughout its length, thereby it can withstand the greater forces. So once again see, with this modification, a greater force is permissible due to uniform distribution of stress, and thus bolt becomes number one, stronger, as the material is removed at the shank part becomes lighter. So two benefits are there. One is that the bolt will become more stronger and it becomes lighter also because of removal of the material at the shank part. So what are the different methods? How to make the shank part equal to root area? How to make? What are the different methods adopted for this achievement? So let us see different methods of making bolts of uniform strength. The shank area is reduced. That means area will be reduced by root to the root area by turning down. That means whatever the length of the shank part is there, that should be turned down to the root diameter, reducing the diameter of the shank to the diameter of the root. That is one method. And next is another method is, let us drill a hole through the head up to the threaded portion. Let us drill a hole through the head of the bolt up to the threaded portion. So drilling an axial hole through the head up to the threaded portion. These are the two methods available to get a bolt of uniform strength. One is reducing the shank area by turning down to the root diameter. Number two is drilling an axial hole through the head up to the threaded portion. These two methods are there. So let us see making a bolt of uniform strength, method one. See here, from here to here, this is the head, and from here to here it is the shank part, and this is the threaded portion. So here in this figure, the diameter of the shank part is same as the nominal diameter of the threaded portion. So with this, the shank part will become more stronger, whereas the threaded portion will become weaker part. So in order to manufacture this type of bolts, let us see in this figure. The shank part is reduced to a diameter of root. That means by turning of the shank shank length to a diameter equal to core diameter. That means this will become now core diameter, whereas in the previous case this is the nominal diameter. So now it will become equal to core diameter, means DC. This is the first method. So the shank of the bolt is turned down to a diameter equal or slightly less than even. Sometimes if you need, you can reduce slightly less than the core diameter also. Right? So this is one method. That means the shank will absorb a large portion of the energy. So this is method one. Right? So next method, let us see. This is the method two. In method 1, we have reduced the shank diameter by turning down. Now, in the second method, same as in the previous, head, shank and threaded portion, which is the shank is equal to the diameter of the nominal. Now let us see in this second method, we are going to drill a hole, axial hole, through the head, hexagonal head, or maybe another form of square head, whatever it is, round head, whatever it is, throw the head up to the threaded portion, up to the threaded portion. That means here in this figure it has given wrong, and this must be to a length of thread. The length of the hole should be up to threaded portion through the head. So that means, say D will be the hole diameter and DO will be the nominal diameter or major diameter, and DC will be the core diameter or minor diameter or root diameter. So an axial hole is drilled through the head as far as the portion, because of which the shank area of shank becomes equal to the root area of the thread, right? So this allows the uniform distribution of stress throughout the bolts. These are the two methods we are going to follow to make the bolts of uniform strength. So how to determine the hole diameter? We are in the second method, we are discussed about drilling an axial hole through the head up to the threaded portion. But what may be the diameter of this hole? Let us see, as we have discussed one thing, the shank area must be equal to the root area. So let us see, D will be the diameter of hole to be drilled and DO will be the outer diameter or nominal diameter of the thread, and DC will be the core or root diameter of the thread. So in this, so this is the area of the hole is also equal to, this is the area, right? So finally we will get D square is equal to DO square minus DC square. Finally we will get D diameter of the hole to be drilled is equal to under root of dy square minus dc square. This formula is used to determine the diameter of the hole to be drilled to make the uniform strength, where d is the diameter of the hole to be drilled. So let us see one simple problem that is there. So here the problem, determine the diameter of hole that must be drilled in M48 bolts, M48 bolts, such that the bolt becomes uniform strength. So here the given diameter is M48. That means M is the stands for metric thread and 48 stands for nominal diameter or outer diameter or major diameter in millimeters. So with this 48, D is equal to DO is equal to 48 is used to calculate the core diameter. So dy is the 48 mm. Now corresponding from the table, dy is equal to 48 mm and dc is equal to 41.795 millimeters. Or also whenever there is no availability of table, you can use dc is equal to 0.84 times of do. So with this you can calculate both do as well as dc. And now let us see the formula. D is equal to hole must be drilled. That means hole to be drilled, diameter of the hole to be drilled is equal to, so under root of d square minus dc square, 48 square minus 41.795 square. Finally you will get 23.64 millimeters of diameter of hole must be drilled in a bolt of M48 to make the bolts of uniform strength. Okay, friends. So this is how to make a bolt of uniform strength, the concept of bolts of uniform strength, right? So now let us see strength of screwed joints. Strength of screwed joints. The screwed joint may fail in any of the following ways. Let us see what are the ways. Number one is tearing across the root of the screw threads. Tearing across the root of the screw threads. And number two is stripping the screw thread in the nut itself. Stripping off the screw thread in the nut. And next is, and last is direct shearing of the bolts. These are the three ways the screw joint may fail. One is tearing across at the root of the screw thread and stripping the screw thread in the nut and the direct shearing of the bolt. Number one, tearing across at the root of the screw threads. This will occur if the size of the bolt is smaller. This will take place if the size of the bolt is smaller. Then if P is the tensile load acting along the axis, that is tensile load acting along the bolt axis, then the suitable diameter may be obtained by using the relation P is equal to tensile load sigma T pi dc square by 4. This is the core area of the core, whereas this is the tensile stress, where dc is equal to core diameter and sigma T is equal to permissible tensile stress. So with this, and P is equal to tensile load. So tearing across the root of the screw thread. Number one, failure. Number two is stripping the screw thread in a nut is a common case of failure. That means the threads may be failed by stripping action. So it may be prevented by increasing the shear strength equal to the tensile strength of bolts. This can be prevented. This failure, that means stripping of the screw thread in a nut, can be prevented by increasing the shear strength of the bolt to the tensile strength of the bolts. That means equate the shear strength equal to tensile strength. With this, you can achieve the stripping of the screw thread in the nut. The failure may be achieved. So this is also design of nut. This stripping of screw thread is also same as the design of nut. So to avoid stripping, a suitable thickness or height of the second method is, first step is making the shear strength equal to the tensile strength, number one. Number two is to avoid the stripping, the suitable thickness or height of nut and number of threads to be calculated. So means increasing the length of the engagement of threads. That means height of the bolt should be increased. Thereby you can achieve this, you can avoid this problem. First one is, let us see in the previous, it may be prevented by equating or increasing the shear strength equal to the tensile strength. First method, to avoid the stripping of screw thread in the nut, and second method is increasing the length of engagement of screw threads. That means by increasing the height of the nut. By increasing the height of the nut. This is the second method. This entirely is also we can study under the design of nut. And last one is direct shearing of the bolts. So this will happen in case of generally the flange couplings. There are two flange couplings One is stationary and the another flange is with the driver shaft and another is driven shaft. First one will move, it has to, the second one has to move along with this, thereby it will takes a little bit time, thereby sometimes if it is not cope up the second, that is driven shaft, driven flange, if it is not rotating, the shearing of the bolts may take place. So direct shear force acts on the plane of slipping between flanges of couplings in a machine members, in machine member. So direct shearing force acts on the plane of slipping between flanges of couplings of machine members. So P is the shear load acting perpendicular to the axis of bolt. P is the shear load. Then P is equal to, shear load is equal to tau into pi d square. That means shear area. Pi into tau into shear, that is shear stress into shear area, where d is the nominal diameter of the bolts and tau is the permissible stress, shear stress in the bolts. Next is height of nut. Height of nut. Let us see height of nut. To calculate the height of nut and the number of threads, consider the shear resistance at the bottom of the threads. Consider at the bottom of the threads, right? So this is the hexagonal nut and this inner side is the threaded portion. And let us see. Consider the shear strength of screw threads is equal to shear load is equal to shear area of the thread into shear stress into number of threads. Shear area of the thread into shear stress into number of threads. So shear area is pi into diameter into T. That is, this is the circumferential length and this is the thickness of the nut. Now tau is the shear stress and n is the number of threads. And next is P is the pitch, D is the nominal diameter, T is the thickness of the thread and n is the number of threads. And tau is the shear stress. Tau is the shear stress. So using the above relation and another relation, T is equal to P into N, where T is equal to height of the nut and P is the pitch of the screw thread and N is the number of threads. Once again, T is equal to height of the nut and P is equal to pitch of the screw thread and N is equal to number of threads. Now let us see in some more problems. Another problem. In a mesh testing machine, the problem is, in a testing machine, a square threaded screw has to withstand a tensile load of 550 kilonewtons. The nominal diameter of the screw is 100 millimeters and the pitch is 20 mm. Now let us find the height of the nut if the average shear stress in the screw thread is 25 Newton per millimeter square. So as previous discussion, in order to avoid the stripping of the bolt, let us discuss, we have discussed it in the previous case, to make the shear strength equal to the tensile strength. So that means tensile strength is equal to shear strength. So tensile load P is equal to 550 kilonewtons and 550 into 10 to the power of 3 newtons, and the nominal diameter of the screw is equal to 100 millimeters, it is D, and pitch of the screw is equal to 20 millimeters P, and thickness of the thread T is equal to, thickness of the thread is equal to P by 2. That means pitch by 2, that will get 10 mm. And the shear stress in the screw threads is equal to 25 newtons, which is the given to you. Consider the shear strength of the screw threads equal to tensile strength. The tensile load P is equal to shear area of the thread into tau, where N is equal to number of threads in engagement, that is 550 into 10 to the power of 3 is equal to pi dt into tau into N. So N is equal to, you can take, finally you will get number of threads in engagement is equal to 7. So height, let T be the height of nut using the relation T is equal to Pn, P already given to you, and height of nut should be calculated, and already you have calculated in the previous. So 7, this is 7. So 20 into 7, height of nut is equal to 140 mm. This is the problem. You can see once. Let us see once again this problem. So in a testing machine, a square threaded screw has to withstand a tensile load of 550 kilonewtons. The nominal diameter of the screw is 100 mm and the pitch 20 mm. Find the height of nut if the average shear stress in the screw thread is 25 newton per millimeter square. Now to get height of the nut, P into N, T is equal to P into N, where T is the height of the nut, which is equal to P into N, and P is already given to you 20 mm, but N is not there. In order to calculate N, the tensile load should be equal to the tensile shear load, that is shear strength. Tensile strength is equal to shear strength. Thereby, 550 is equal to shear area into shear stress. And now thickness of the thread T is equal to P by 2. So with this relation, P is equal to pi dt into tau into N, you can calculate N value, that is number of N is equal to 7. So T be the height, which is equal to P into N, that is 20 into 7 is equal to 140 millimeters. So this is the final answer. So with this topic, once again let us review the total in this lesson, the summary of this lesson, today's lesson. We had discussed about the bolts of uniform strength. Why? What is the need of bolts of uniform strength? Also we had discussed the main need is the shank diameter is more when comparing to the shank diameter is equal to the nominal diameter of the threaded portion. Thereby the shank strength will be more than the threaded portion. That's why you have to make the threaded portion will become weakest part. Whenever there are impulsive forces are acting, there is a possibility of failure at the threaded portion. So we have to make the entire bolt of uniform strength. For that we have discussed two methods. Number one method is reducing the shank diameter equal to the pole diameter by turning them. And next method is, second method is drilling a hole through the head of the, drilling an axial hole through the head up to the threaded portion. These are the two methods. What is the need of bolts of uniform strength? What is meant by bolts of uniform strength? What are the methods for bolts of uniform strength we are discussing? And also we have done one problem also. And what is the size of the hole to be drilled? And that also we have discussed. We have completed one problem. And next is different methods of obtaining bolts of uniform strength we have discussed so far. And also strength of the screw joints. The screw joints may fail in three different possibilities. Number one is the tearing across at the root of the screw thread. First one, failure. And second cause of failure is stripping of the screw thread in the nut itself, and the third is direct shearing of the threaded portion, right? These are the three possible failures. If you are able to overcome all these problems, the screw joint will become more strength. And the next is design of nut. How to design? In order to design of nut, first we have to make the shear strength equal to the tensile strength. So shear strength is equal to the pi dt into tau into n, where d is equal to nominal diameter and t is the thickness of the thread, and tau is the shear stress induced in the thread, and n is the number of threads. So after that, let us discuss, let us find the value of height of the nut. That means length of engagement of the nut with the bolts. So T is equal to height of that, which is equal to pitch of the screw thread into number of threads. With this, we have completed. So design of nut also, and also these are the 4 points: bolts of uniform strength, different methods of obtaining bolts of uniform strength, strength of the screw joints, design of nut. Now let us have a simple quiz questions. Weakest part of the bolt is at. The weakest part of the bolt is at. As we have discussed already, the weakest part is threaded portion. Among the threaded portion, first option is head of the bolt, outer diameter, that means nominal diameter of the bolt, core diameter of the bolt, none of the above. Which is the right answer? The weakest part, as we have discussed, threaded part. Among the threaded part, head is not the